So the fundamental theorem of algebra tells us that we're gonna be able to break this down into 3 linear factors. All right, so there's the graph of it. So if I look at this, how many real zeros do I have? 1, because we got one x-axis, or one x-intercept right there. Okay, so x equals 2 is a real 0. All right, and then we know we got to have 3 altogether. So then you're going to have 2 complex, because these 2 have to add up to be 3. Because our equation is x cubed minus 4x squared plus 6x minus 4. So they got to add up to that exponent. All right. So then it says write it as a product of linear factors. So when you're done with this, we're going to end up with 3 linear factors. All right, so we already know that 1 is a 0. So x equals 1 is, or no, not x equals 1. X equals 2 is a 0. Okay, so that allows me to take that and I can write out what factor it would be. That would be the solution to a binomial of x minus 2. Okay, so this is one linear factor. That is a linear factor, and now what we want to do is we want to find the other 2. So we got to get this linear factor and this one. All right. So if you remember what we did, we're going to take this polynomial and we're going to divide it by this factor. Okay? So we did synthetic division to do that. Right, so let's see, this is called f of x. All right. So my first step I'm going to do is I am going to divide f of x by x minus 1. Or no, x minus 2. And the way that we did that is we used synthetic division. Using synthetic TIC? How do you spell synthetic?
S-Y-N
T-H-E I-C? Really?
T-I-C.
T-I-C, that's what I thought. Okay. I know. T-I-C. All right. Bye. All right. So to do that, the root of this is a 2. And then I take my coefficients, which would be a 1, a negative 4, a 6, and a negative 4. All right, so I bring down the 1, 2 times 1, 2, add them up, negative 2. 2 times negative 2, negative 4, add them up, 2. 2 times 2, 4, add them up, 0. Okay, So what this does right here, this gives me what's left over once I divide. And it's going to be x squared minus 2x plus 2. All right, so now what you do is you're going to find the roots of this this is called a reduced polynomial. So now we're going to find the roots. Find roots for x squared minus 2x plus 2. And since they're complex, we know we can't factor this. So we're going to have to use the quadratic formula. Using the quadratic formula. Okay, so I'm going to put that right up. That's x equals the opposite of b plus or minus b squared minus 4ac divided by 2a. Okay. So x equals, okay, the opposite of b would be positive 2 plus or minus, okay, b squared minus 4 times 1 times 2, all divided by 2 times 1. Plus or minus. Okay, and underneath here, I'm going to have 4 minus 8. So that's negative 4. So then I have x equals 2 plus or minus. Okay, the square root of negative 4 is going to be plus or minus 2i over 2. And then I can break this up into 2 fractions and simplify it. So it's 1 plus or minus I. Okay, now what we do is that's the solution for the next linear factor, 1 plus I. And then the solution for the other linear factor is 1 minus I. Okay, and now you can write out your linear factors here. That's the roots. Okay, so this is going to be x minus 1 plus I. And this one is going to be x minus 1 minus I. And there's your solutions. All right, so if we expanded this, okay, we want to know what would be the number in front of this term. All right. So we know this is going to be the 5th row. So that's this one right here. And then the coefficients, guys, those are the same as doing the combinations. Okay, so for example, that coefficient right there is the combination of 5 choose 0. That's that 1. That equals 1. The next one is 5 choose 1, which is 5. And then 5 choose 2, which is 10, and so on. 5, choose 3. 5, choose 4. 5, choose 5. And then we had a formula for those as well, okay? This was NR, and this equaled n factorial over r factorial times n minus r factorial. Okay? And then the other thing that we knew was CR, then what this would be, R was here, and then this was n minus r. Okay? So you can use the 3 and the 2. So you got x3, y2. So you already know what r is. So when I look at this part right here, C equals, there's my r. So I know that's 2. And then this part has to be n minus r. That has to equal 3. So n has to be 5. So 5 choose 2, 5 choose 1, 0, 5 choose 1, 5 choose 2, 10. So the coefficient on that is 10. Okay. Factorial over that. 3 factorial. I'll just do all the work for it. So this would be 5, 4, 3, 2, 1, 5, 4, 3, 2, 1, 2, 1, and 3, 2, 1. And then those are going to cancel. And then this 2 I can cancel out with that 4, and that gives me 10. Okay, so it says select all that, what are the equations that could be represented by this drawing? All right. Okay. Okay, so number 3. So I just copied and pasted some of the relevant information from the Chapter 7 notes, okay? Okay, let's see here. Let's get this out of the way. Sorry, guys. Too much cutting and pasting. All righty. So we want to figure out which one of these would apply. And there could be more than one. Well, one thing you know is that the major axis is the x-axis. Okay, so you know it's going to have to look like it's going to fit this format right here, where you're going to have x squared, a squared, y, squared over b squared. It looks like I typed in an x there. That should be a y. All right, and that has to equal 1. So this is telling you that the value under x has to be bigger than the value under y. This is going to be the larger of the two. So if I look at these, I'm looking for the ones that have to be where whatever's under the x has to be larger. Right? Because remember, when we did this part, this is the real number. So that would make this 5. That would be the imaginary axis. That would be 3. So yeah, that makes sense. That is longer than the covertex. So that could be one answer. Okay? It can't be the first one because 25 is smaller than 64. So the larger value has to be under the x squared value because of the way that it's laid out.
And you can't do the fourth one because that's hyperbola.
Okay, this, right? Because that subtraction makes that a hyperbola, not an ellipse. Okay. Can't be that one because the real axis is shorter than the imaginary, which is not true. Okay. Could it be the last one?
Yes.
Yep, that one's a possibility. Okay, could it be the third one?
Yes.
Yeah. This one, the y is the major axis. So you're just looking at the drawing there. All right, number 4 now. An ellipse is graphed, the ellipse below has 2 focus points, F and G, at the vertices shown. Okay, so these are the focal points right here, F and G. Every point on the ellipse, PF plus PG equals K. All right, so what that's dealing with is this idea right here. Okay, anytime you add up these two, so if I picked a point on here, let's say I just picked a random point P. If I drew this distance, okay, that's P to F, P to F, and then I drew the distance from P to G, that's P to G. What does that have to add up to? Okay, over here we called this was the first distance. This was the second distance. What does that have to add up to?
20.
Right, this adds up to 2 times A. Okay, so when I do this, it's going to add up to this length. Okay, that's A, and that's A, so that's 2A. Okay, so they got to add up to, in this case, 2a is equal to, what's this going to equal? This, we know this is 2a, and, well, let's put 2a there. How long is 2a? What's a in this case? 10. So a is the distance from the center to the vertex. And then a on this one is also 10. So 2 times 10, that is going to be 20. So the value of k is 20. That's called the special sum. Okay? So these two things, when you add these guys up, that's going to equal the distance between the vertices. Okay, A is the distance from the vertice to the origin. So that's why it's half this distance. Now, here's what you know on this one, is that you take the differences of the two distances, not the sum like we did before. And that's equal to the distance between the two vertices. Okay, so if I did 8, take away 2, that's 6. So that's telling me that this is 6, so A has to be 3. A is the distance from the vertex to the origin. All right, we'll stop there.